Hi everyone, my name is Gideon Besaidnout and I am an application engineer for Micrographics. Today we're going to have a look at generative design using the shape generator tool in Inventor. Now this allows designers to optimize models by reducing mass while maintaining structural integrity. You can also define properties like material, constraints and loads. The system also generates a shape suggestion that helps you to streamline the design process. I'm just going to go and open a normal part. Yeah, I've got a nice cast part, and I'm just going to open it. As you can see, it's just a normal cast block that we can utilize for the shape generator. Now the shape generator tool in Inventor allows you to create lightweight models by defining design requirements. The process begins with the initial model that represents the approximate volume or shape required or needed. Now, how do we utilize the shape generator? First step, you open the shape generator, so you navigate to the 3D model tab, and in the Explore, here we see shape generator. From here, we can go and create a study. You'll notice this window appears and it just explains a little bit about the shape generator for conceptual studies. Now once you say OK, you'll notice it's quite easy to start adjusting for a shape generator. You can move from left to right, or you can even look in your model browser and it will also tell you what you'll need to do. Now the first instance is we need to assign materials. Here you can see we've got steel and it's carbon. The override material, so here you can choose if you would like to create a different material. Let's go to cast iron. Steel carbon. And here you can choose your safety factor. Would you like to use the yield strength or the ultimate tensile strength? Now in this instance, I'm going to use the yield strength and I'm going to say OK. You'll notice in your model browser, we've got our material that we've assigned. Next, we're going to have a look at all the different constraints and what they mean. Now the first constraint would be the fixed constraint. Just going to hover over it. Now this fixed constraint, it removes all the degrees of freedom from a selected face, edge or vertices. You've got the pin constraint that is used with cylindrical surfaces to restrict movement or deformation in a radial, axial or tangential directions. We've also got our frictionless. When we think about the frictionless, now this is usually applied to a flat or cylindrical surface to prevent movement or deformation in the normal direction relative to the surface. Now when we're going to apply constraints, we need to select the appropriate constraint type, choose the location, for instance where it's going to be constrained, so a face, an edge or vertices. And then we need to use the advanced settings to further customize the constraint behavior. I'm going to choose a fixed constraint, and here at the options, I'm going to go and choose the back as a fixed point. It means the back won't move, and then you can simply say apply. You can choose your vector components, so you can choose your X, Y, and Z. I'm going to choose 2 points as fixed. Yes, you can go and choose your pin. When you choose a pin, you can see it's a fixed radial direction, actual direction, tangent, and so on. So it's quite easy if you want to go and utilize, let's say, those holes as an example. Now we've got quite a few constraints. We can also choose the different types of loads. Now, when we're applying loads in the shape generator, we need to determine a shape using the shape generator. You can assign various loads that represent real-world force acting on the model. We're going to have a look at all the different types of loads. First, we get our force. Now this assigns a force to a face or edge. The force is directed inwards by default, but you can adjust it using reference planes, faces, and so on. You've also got your pressure. That applies a uniform pressure to a face, acting normally to the structure at all points. You do have your bearing that assigns a load to a cylindrical face. Moment that applies a rotational force to a face, and this direction can be referenced using planar faces, straight edges, or axes. And lastly, your gravity. Now this just applies a normal gravity load to a normal or selected face. Now in this instance, I'm going to say choose force. I'm going to choose the location. I'm going to choose the top side, and here you can see the scale and the newtons. So I'm going to say, let's say 10,000 newtons just as an example, and you can apply. So that means it's going to have quite a significant amount of force from the top. You can go and set all your different types of loads. After the loads, you can also choose if you would like to preserve specific regions. Now, if we're going to preserve a region, you can select the specific region and you'll be able to draw a block around that region. So just to show you, for instance, if I want to preserve the back part, you can also go and adjust, and you can specify the specific positions. That means that inside face would be preserved if you'd like to apply it. When it comes to the symmetry plane, now that forces the generated shape to be symmetric, depending on your symmetry plane that you'd like to select. Now I'm going to leave the symmetry plane and preserve region as is. Select the shape generator settings. We can see the original mass. We can choose the target by percentage that we want to reduce the item with, or we can specify a target mass. So let's say I want that to be reduced by 30%. And here you've got your coarse value with your mesh resolution. I'm just going to say OK, and now we can go and generate the shape. You can view the mesh view, or you can run the generator shape. From here, you just run your study. As you can see, it's busy starting calculating and computing the results. Now, after the study has been completed, you'll see it generated a mesh. And with this mesh, it actually tells you and shows you the type of material that you actually don't need. With this newtons that it takes, you can actually save almost half of the block if it only has a normal force from top, and if the back part it is actually going to be fixed. So you can go and promote this to the shape. You can also see a report. When you generate the report, you can see you can choose a complete or custom, the general properties, the save documentation, the properties, the studies, the format, and so on. And it would save a HTML format for you to actually see the report. And when you promote it to the shape, you can choose if you want to convert it to a STL file or to the current part file. So if I'm choosing the current part file, you'll see there's the recommendations, and here you'll be able to see the mesh, and you'll be able to cut out some unnecessary material by creating 2D sketches and making your modifications and keeping the mesh part as is. Now obviously when it comes to this type of study, it's very important to keep in mind that you'll still need to just do actual FEA analysis just to confirm the results and that everything is working, and when you make your modifications to the model, that it is actual practical modifications that you are making to the model. Thank you guys for watching. I hope you like this video. This is just a short introduction to the shape generator and using the initial setups within Autodesk Inventor. Please like and subscribe and follow for more content.